Okay, so I'm going to do an example about division with decimals. And I wanted to show you there is more than one way to set up a fraction. We can write it this way with the bar in between. We can write it with the numerator over the denominator. And then we can write it with this using this operation sign. And as you can see, there's more than one way. And we can also write it in a sentence form. So whenever we have to divide by anything, we look at it and we have to clean up whatever restricts the fraction from dividing out properly. So in this case here, we have this denominator here. It's also called a divisor. It has a decimal in it. And that's one rule we can't have. We can't have a decimal in the denominator, in the divisor. So what we got to do is we got to move the decimal however many places we need to the right to make it a whole number. Now, whatever we do to one part of a expression, equation, function, we have to do to another part. So I'm going to grab this decimal and I'm going to move it 1, 2 places to make it a whole number. That means I need to grab it here on this numerator and do the same way. Move it 1, 2. And then I'm going to rewrite my fraction. I got 4,000, 4, 5, 0, 5, 7, 0, 0. And it's all going to divide by 1,525, or 1,525. There's no end there. So now that I got my divisor, my denominator as a whole number, and I applied the same method to the numerator as I did the denominator to make it a whole number, now I can go to the next stage. The next stage says, I'm going to set it up as long division and divide it out. So let's get this going. Right kind of big. So my divisor, my denominator, goes on the outside. I call this a doghouse for multiple reasons. A lot of times people are scared of division. So we're going to put the top number in the doghouse, and we're going to see what it takes to multiply to 1,525 to get this number here in the doghouse. Okay, so first thing I do is I notice there's 4 digits here. So we know we need to at least look at 4 digits here before we go any further. There's no way we're going to say these 4 digits is going to go into 45. That's only 2 digits. So a lot of times there's a lot of critical thinking going on here. So what I'm going to see is how many times, and let me highlight it right quick. How many times will this 1525 go into the 4505? 4505. So I'm going to see how many times it would go into it. And sometimes we need to scratch a piece of paper to do multiplication on the side. And one way to do multiplication on the side is we can see that if I doubled that 1525, will it get me to 3,000? That should be a 5. I was thinking 3. So 3. So now I'm going to write my times is by 3 and see how close it gets me. Because 4 I would think would go over, but we're fixing to find out if we need to use 4. So 3 times 5 is 15. Carry the 1. 3 times 2 is 6 plus 1. 3 times 5 is 15. Carry the 1. 3 times 1 is 3 plus 1. So we busted. So 3 was not my best choice. So we're going to go down 1. Let me get this. And I'm erasing just to save space, guys. Usually on paper, I don't. I just put a mark through it saying this one won't work and move on and try another one. So let's multiply it by 2. 2 times 5 is 10. Carry the 1. 2 times 2 is 4 plus 1 is 5. 2 times 5 is 10. Carry 1. 2 times 1 is 2 plus 1. So I'm going to put the 3, or excuse me, I'm stuck on 3. Apologize, guys. This fixed. I'm going to put the 2 right here above this 4th digit. Okay, if this is the ones that we're working with, then that's where I want to put it. And I'm going to bring this 3050 down under 4505, and I am going to subtract. So 5 minus 0 is 5. I can't pull 5 out of 0, but I can borrow, right? I can borrow from this 5 over here, making it a 4, and carrying my 1 over here. So now I have 10 minus 5, 5. 4 minus 0 is 4. And 4 minus 3 is 1. And if you are ever in doubt, you can always check your math by taking the smaller number and subtract or adding them together. So what I mean is you can take the smaller number right here and add it to your answer here. If it gives me back the 4505, then we know we did it right, okay? So next, we're going to bring down the 7. Okay, and now we gotta see how many times will 1500 go, or 1525 go into the 14557, and sometimes we have to play with bigger numbers. So if I multiply it by 10, it's gonna tack on another 0, making it bigger. So let's try one less than 10. Let's try 9. So I'm gonna erase this math work over here. All right, so let's try 9. So I have 15, 25. So 9 times 5 is 45. Carry the 4. 9 times 2 is 18, plus 4 is 22. 9 times 5 is 45, plus 2 is 47. Carry the 4. 9 times 1 is 9, plus 4 is 13. I'm going to put my 9 because it didn't bust. It didn't go over this 14557. I'll put my 9 there, and let's bring our 13, 7, 2, 5 here. 7 minus 5 is 2. 5 minus 2 is 3. I can't take 7 out of 5, so I'm going to have to borrow. And I meant to change this color. Change it. So I got to borrow from this 4, making it a 3, and add the 1 to the 5, make it 15. So 15 minus 7 is 8. And now we're going to bring down the 0. And then we're going to see what else it would go into. So guys, whenever we're looking at this, the next option, we see 15, 2, 5. We're wanting to know how many times will it go into 8, 3, 2, 0. Well, one way to look at it is if I multiplied that 15, 2, 5 by 8, we know it's going to bust. So let's multiply it by, apologies, let's multiply it by 1 less, which is 7. Let's see what that does. So I got 15 to 5 times 7. So 7 times 5 is 35. Carry the 3. 7 times 2 is 14, plus 3 is 15. Carry the 1. 7 times 5 is 35, plus 1 is 36. Carry the 3. Oh, I apologize. 7 times 2 is 14, plus 3. That's a 7. Yay. When we're in a live class, I like it when we have interaction where you can actually say, are you sure? Because that helps me know that you're paying attention. So 7 times 1 is 7 plus 3 is 10. So again, 2 times 7 is 14 plus 3 makes 17. So, okay. So this gives me an answer of it busted 10,000. So 6 would probably still bust. Let's try 5. Okay, 7 was too big, so let's try 5. All right, so let's try 5. So 5 times 5 is 25. Carry the 2. 5 times 2 is 10, plus 2 is 12. 5 times 5 is 25, plus 1 is 26. Carry the 2. 5 times 1 is 5, plus 2 is 7. That's our number. So we're going to use 5. So now we got 76, 25, and we're going to subtract these. Should stay consistent on those colors right quick. My lines are not perfect, if you'll notice. Bring it up a little bit. All right, so back to this. So now I'm going to subtract, but what I noticed is I cannot take 5 out of 0, so we're going to have to come over here and borrow, making this a 1 and carrying the 1 over here. But I cannot take 2 out of 2, so we're going to have to come over here and borrow again, right? Make it down 1 and bring the 1. Well, I can't take 6 out of 2, so I got to borrow again, making this a 7 and bring the 2, or bring the 1 over. So now 10 times 5, or excuse me, 10 minus 5 is 5. 11 minus 2 is 9. 12 minus 6 is 6. 7 minus 7 is 0. So we're done there. Let's bring down this other 0. All right. So let's look at this and decide on what's our next option. 5 gave us 76. Let's try 4. There's a possibility that 4 will be our good number. All right, so 4 times 5 is 20. Carry the 2. 4 times 2 is 8, plus 2 is 10. Carry the 1. 4 times 5 is 20, plus 1 is 21. Carry the 2. 4 times 1 is 4, plus 2 is 6. Yeah, that's going to be our number. So now we're going to bring the 4 up here. And let's subtract our 6,100. All right, so 0 minus 0 is 0. 5 minus 0 is 5. 9 minus 1 is 8. And 6 minus 6 is 0. What happens is we got a remainder of 850. The reason why I say a remainder is because we ran out of digits right up here in the numerator. So in order to go further, we need to add a decimal and add a 0 and bring that decimal up here to the top. It's very important you bring that decimal up there. That's where it goes. Depending on what you are asked to round to, it depends on how far you need to go out. So we're gonna round to the nearest hundredths on this problem, and then that will give you an idea. If it says don't round, then usually there's a stopping point somewhere. If it says round, it's because the digits usually go way, way out. So I'm gonna round to the nearest hundredths. That means I gotta go out 3 decimal places in order to round to the nearest hundredths. So let's look at what we got to work with. If I bring this 0 down, what do I have? I have 8,500. I noticed that when I times it by 5, I get 7625. So let's try 5, okay? We're going to put the 5 up here, and we're going to say 5 times that 1525. We're going to bring it down, which we already know because we did it a while ago. So we got 76.25. Subtract. And what I noticed is I can't take 5 out of 0. So I got to borrow from the 0. And 0 is actually seen as 10. So what's 1 less than 10 is 9. And I'm going to bring the 1 over here. And then I see 2 will come out of 9, so we're good. But when I look to the next digits, I see 6 cannot come out of 5, so I got to reduce this one. Make that a 15. So you notice this 9 stopped here. But actually, my apologies. We definitely want to double check our work on this, because sometimes when we subtract, we kind of, I mean, we're all human, right? We kind of get into that mindset of we don't borrow no further. But technically, we do need to, because in order to make the 0 a 9, we had to pull from this 5, right? We had to keep pulling until we actually come up with something. So my apologies on the typo. That's a good checkpoint. A lot of people ask these questions, so it's good to brace this up as an issue. So what I'm going to do is, in order for this 0 to become a 9, I had to borrow from this 5, right? And it made it a 4. But this 4 is still not bigger than 6, so I have to borrow from this 8, making it a 7, and put that 1 on the 4. Kind of see what happened is, we started with 0, it rolled into another 0. Well, we can't make 0 a 10 to reduce it by 1 until we pull from the 5. And then, of course, then it's still not big enough because originally the 5 was smaller than the number it had been subtracted from. So we had to run borrow from the next one. So now we can do this. 10 minus 5 is 5. 9 minus 2 is 7. 14 minus 6 is 8. 7 minus 7 is 0. Then we're going to go back up to the top and add another 0 because we got to go out 3 decimal places because we're trying to find the hundreds place. So let's clean this all up right quick. And I probably needed that because we have, let's look at this answer, our remainder down here. It said 875, and we're got to bring down this 0 here. Bring it down. So let's try 7 or 5 again, right? Because 5 times at 1525 gave it 7625. Let's try 5 again. So I'm going to bring it back up here to the top. So this becomes 7625 down here underneath the 8750. Now let's subtract. We have that issue again where we have 5 being pulled out of 0, and we can't do that, so we got to borrow from this 5, make it a 4, carry the 1. Well, this 5 originally was bigger than the 2 because we could stop there. So 10 minus 5 is 5. 4 minus 2 is 2. 7 minus 6 is 1. 8 minus 6 is 1. And we need to round one more time, right? So on the 0 here. Bring it down. Again, if it doesn't look right, guys, it doesn't hurt to check your work. It's always a good idea to check. If you don't agree with what your answer appears, you can always check it. There's nothing wrong with that. A calculator is good to check your work, not to give you your answer. You need to know how to derive at the answer you got. So we got 1125, and we're trying to see how many times we need to take that 1525 to. So 1125, 0, let's think about this. If I was to say at 5 times that gave us the 7625. Let's try 7. We don't want to go too big, guys. Go too big, and then we can always subtract. You know, if we go too big, you can subtract down until you get the right answer. And what do I mean is, let's take we said the 5 times this here. Let me show you how to do this if you get to this point and you're kind of stuck. We know this because we already did this multiplication. Okay, so this is not big enough. So what we need to do is add another 1525. What does that mean? That means it's times 6. Okay, so add it. 5 plus 5 is 10. Carry the 1. 2 plus 2 is 4. Plus 1 is 5. 6 plus 5 is 11. Carry the 1. 7 plus 1 plus 1 is 9. It's not big enough, right? Because there's still going to be too much room. And if it is too big, let me show you. Let me go another step. Let's add another. And what does that tell me when I add this other 1525 to it? That means it's 7. It's times 7. Okay, so 0 plus 5 is 5. 5 plus 2 is 7. 1 plus 5 is 6. 9 plus 1 is 10. Okay, I believe this is going to be the one we're going to work with, but I want to show you what I meant. So if I wanted to go another step and add one more on here, add one more set, it'd be times 8. All right, so this would be times 8. So 5 plus 5 is 10. Carry the 1. 7 plus 2 plus 1 is 10. Carry the 1. 6 plus 1 is 7 plus 5 is 12. Carry the 1. 1 plus 1 is 2. Bring down the 1. We busted. So if you ever started out big, you can always subtract the 1525 and go down 1 and make it, it's 8 times, it will go down 1 and be 7 times. So that is a shorthand for people who struggle with the multiplication process. And once you pick a number and you multiply it, you can add to it or subtract from it to get to the part you need. So this is just a little side note. Hopefully it helps. So I'm going to choose the times 7. So just to keep me from writing the wrong answer, I want to erase this times 8. Keep me from making that mistake. And I'm going to write the 0, 0. Oh, gotta scoot over, right? No, that's right. 6, 7, 0. And I really don't need to subtract this out because what we need now is to round, right? Because all we needed was this thousands place to determine what happens to the hundreds, and then I would have my answer that I needed. So our question falls on this here, this thousands. This thousands place says, what's going to happen to the hundreds? Because I asked at the beginning to round to the nearest hundreds, or, you know, beginning of this division part. So it's a simple yes or no. Is this 7, is it equal to or greater than 5? Yes or no? And it is. Yes, it's greater than 5, so it answered it, satisfied the question. So if it is, that means I'm going to add 1 to this hundreds place, and I'm going to drop this off. If my answer would have been no, we wouldn't add 1, but we still drop the 7 off. Does that make sense? So now my answer is 2954.56 because I added 1 to that 5 in the hundreds place. That is my answer. Thank you, guys.